Hello everyone, my name is Silpa Potluri and I am a staff software engineer with over 20 years of experience in software development and more than a decade of specialization in the payments industry. Today I'll be talking about a transformation that's reshaping the financial technology world. How DevSecOps plays a central role in securing payment gateways during the migration from monolithic architectures to microservices. This shift touches not just technology, but also culture, process, and risk management. So, with that, let's begin. To start, let's take a step back and understand what's happening in the payment gateway landscape. For many years, payment systems were built as large monolithics, stable, predictable, but extremely slow to change. And because they handle sensitive transactions, modifying them was risky and involved long development cycles. But the world changed. We now have real-time payments, international commerce, mobile-first users, and 24/7 consumer demand. As a result, payment process began shifting towards microservices because microservices offer agility, independent scaling, faster updates, better fault isolation. However, and this is important, microservices also introduce new complexities, especially for security and compliance. So, this modernization is not just a technical upgrade, it's a complete reimagining of how security fits into the software lifecycle. With that foundation set, let's talk about DevSecOps. Traditionally, security happened at the very end of the development cycle. Developers wrote code, QA tested it, and only then security reviewed everything. This caused delays, friction, and bottlenecks. And in the microservices world, where deployments happen multiple times a day, this model simply doesn't scale. That's where DevSecOps come in. DevSecOps integrates security from the beginning, embedding it into design, development, build, deployment, operations. It shifts security left, meaning security moves earlier in the life cycle. This ensures that security becomes a continuous, collaborative, and automated part of development rather than a final checkpoint. Now let's start transitioning to a topic that is unavoidable in payments: PCI DSS compliance. PCI DSS defines strict rules for protecting cardholder data, access control, network segmentation, encryption, logging, and monitoring. In traditional monolithic systems, organizations relied heavily on perimeter security, isolated networks, firewalls, DMZs. But in microservices, workflows are distributed. Data moves across many services. Perimeter became less clear. The attack surface grows. So compliance must evolve from being network-based to being service-based. And failure to comply could result in heavy fines, loss of processing privileges, significant reputation damage. In short, compliance becomes a constant priority, not something done once a year. With compliance in mind, let's shift into what changes when you move to microservices. There are three major paradigm shifts: expanded attack surface. Instead of one app, you now have dozens of services, each one a potential entry point. Dynamic infrastructure. Containers and services scale up and down constantly. Security controls must handle rapid change. Integrated security responsibility. Security is no longer owned by just one team. Every team and every service carries shared responsibility. This shift requires new tools, new thinking, and new design patterns. Now that we understand the challenges, let's move into the architectural solutions that help secure microservices. Service mesh. A service mesh provides mutual TLS, encryption, authorization, traffic policies, all automatically, meaning developers don't need to manually code these. Next is API gateways. An API gateway becomes the secure front door. It handles authentication, rate limiting, threat detection, and input validation. Lastly, the zero trust. Zero trust essentially means trust nothing, verify everything. Every service must authenticate and authorize every request, even internal ones. Now let's talk about protecting the data itself. We use a layered approach. Tokenization. Actual card data is replaced with tokens. reducing PCI risk dramatically. Encryption at rest. Stored data is encrypted using strong keys and managed through secure key. Encryption in transit. All network communication is encrypted with TLS. Secrets management. Secrets must be stored in secure vaults, not in code, environment files, or repos. With these combined, we build defense in depth. At this point, you might be thinking, with so many security checks, won't these slow us down? Not if we automate. Automation enables security to keep pace with rapid deployments. We automate static analysis, checks code for vulnerabilities early, and we automate dynamic testing, attacks the running application to find runtime issues. And then container scanning ensures images and libraries are secure and up to date. Automation turns security from a bottleneck into an enabler. Now let's build on automation by talking about infrastructure as code. Infrastructure as code allows us to define networks, servers, configurations, security settings, all as code. This provides consistency, version control, and automated guardrails. Similarly, there is compliance as code, which converts PCI requirements into automated checks. This ensures compliance becomes continuous, real-time, auditable. Instead of waiting for a quarterly or an annual audit, we validate compliance on every deployment. Now let's move into what happens after the deployment. Even with strong prevention, incident will still happen. So detection and response become essential. We rely on SIM systems, which collect logs from everywhere to spot suspicious patterns. Fraud detection models analyze transactions and behaviors in real time. Distributed tracing allows us to trace individual transactions across potentially dozens of microservices. Anomaly detection alerts when something deviates from normal behavior. These capabilities give security teams visibility and actionable insights. Now let's turn our attention to the CICD pipelines, which is often the first line of defense. Source control security. This prevents secrets from being committed, requires code reviews, and then coming to build process, analyzes dependencies and libraries for vulnerabilities and vulnerability issues. Artifact signing ensures all images and binaries are trusted and unmodified. Deployment gates block insecure builds automatically, and then rollbacks allow quick recovery during incidents. Microservices rely heavily on this pipeline discipline. Next, let's talk about the cloud, since microservices often live there. Cloud platforms provide fine-grained identity access management, network microsegmentation, managed security services, automated encryption. However, the shared responsibility model means organizations must still secure application code, configurations, access permissions. Cloud can strengthen security, but only when used properly. How do organizations actually succeed? Here are the proven strategies. Phased migration. Start small, learn, and iterate. Security champions. Empower individuals on each team to be security advocates. Threat modeling. Identify risks early, before writing code. Realistic test environments. Mirror production closely to catch real vulnerabilities. These approaches reduce risk and increase predictability. When implemented well, DevSecOps offers clear benefits: stronger security posture, faster and more reliable releases, easier compliance, better cross-team collaboration, a culture where security is shared, not siloed. Ultimately, DevSecOps aligns both innovation and protection. As we wrap up, let's take a forward-looking perspective. The shift from monolithic payment systems to microservices is one of the most significant transformations in FinTech. But to succeed, organizations must commit to new architectures, robust automation, continuous monitoring, a culture change. Security is not a one-time achievement. It's an ongoing journey. Those who build security-first cultures will be the ones best positioned to handle future threats and industry expectations. Thank you so much for your time and attention.